Good day, everyone. I will begin by introducing the first part of our program, which is the introductory section of STRUCTALIFE. This area is responsible for preparing the user before any assessment starts and making sure that they understand what the system does. The first one is the Start New Structure Assessment. This option initiates a new assessment by prompting you to input the project details, structural parameters, and initial condition data. The second one is the View Saved Assessment, which is the number two. It used this to browse a list of all previously saved or completed structure assessment. The third one is the View Assessment Details, which is to select this to retrieve and display the full, detailed report and calculated lifespan for result of a specific assessment. For the fourth one is it update an assessment. We choose these to modify or add new data to an existing save assessment. Fifth is the delete an assessment, which is the options that allow us to permanently remove a save assessment
and all its associated data from the system. And lastly, for the sixth one is exit. Select this option to close the STRUCTALIFE application.
The program starts with a print header function. This prints a clean banner that welcomes the user and presents the program title. It serves as the first visual element to set the tone of the system. Next is the print intro function. This gives a clear explanation of what Structalife is designed for. It informs the user that the tool evaluates the condition of civil structures by analyzing deterioration factors, environmental exposure, maintenance quality, and load conditions. After that, the print getting started function appears. This section tells the user what they need to prepare, such as the structure's design, lifespan, and the ratings they will input later on. It ensures the user is familiar with the process before entering required information. The next major component handled in this section is the rating instructions dictionary. This dictionary contains the detailed descriptions of all rating levels from 1 to 5 for each structural factor. These include cracks, corrosion, deformation, weather, pollution, seismic impact, traffic load, and maintenance. Each rating explains the severity or condition level for easier and more accurate assessment. Lastly, we have the display instructions function. This function neatly displays the meaning of each rating for a selected factor. It formats the text so it is ready to read, ensuring the user clearly understands the criteria before entering their rating. This entire section focuses on proper orientation, clarity, and guidance before the computation begins. In the second part of the program, the system begins collecting information from the user. This part ensures that all unnecessary numerical values and assessments are gathered correctly. The first function here is get structure details. This asks the user to enter the design lifespan of the structure. This value is important because it becomes the basis for computing the remaining service life later in the program. Next is the get input function. This function displays the rating instructions for each factor and asks the user to enter a score from 1 to 5. It also validates the input to ensure that only correct values are accepted. This prevents invalid or inconsistent data from affecting the outcome. All these inputs come together in the get user input function. This function guides the user through rating all the structural and environmental factors. The user enters their ratings based on the rating instructions displayed earlier. It also asks for the current load percentage so the program can calculate how the structure is performing relative to its design capacity. After gathering everything, the function returns both the numerical ratings and the original values. This will be used for computations and the summary display. This section ensures accurate data collection so the assessment later on becomes reliable and meaningful.
Third section of the program handles all the calculations needed to produce the structural assessment. It begins with the calculate deterioration factor function. This function processes all user inputs and computes the total deterioration using weighted score. It considers factors such as structural conditions, environmental exposure, seismic and traffic impacts, load conditions, and maintenance quality. The final output is a deterioration factor between 0 and 1, representing how much the structure has degraded. Next, the system proceeds to estimate remaining life. This function uses the deterioration factor along with the design lifespan to calculate how many years the structure may have left. It uses an exponential decay formula to make the result more realistic and engineering based. The display summary function follows. This presents all original ratings and the load percentage in a clear and organized table. It lets the user review their inputs before seeing the results. Finally, the get condition rating function interprets the deterioration factor and converts it into readable categories. These include excellent, good, fair, poor, and critical. This makes the assessment more understandable for users who may not be familiar with raw numerical scores. This entire section transforms the user's input into meaningful engineering insights.
The next part of the program deals with the presentation of the outcomes in a way that is readable and helpful for decision making. The display results function shows all computed findings in an organized layout. It displays the design lifespan, the deterioration factor, the condition rating, and the estimated remaining life. This allows the user to see the complete picture of the structure's condition. After that, the display recommendation function generates practical advice based on how many years remain. If the structure still has a long service life, the recommendation will be to continue regular monitoring. If the remaining life is short or the structure is in poor condition, the recommendation may suggest repairs, strengthening, or replacement. The system formats this text clearly so the guidance is easy to follow. Next is display team. This function presents the name of all the individuals who contributed to STRUCTALIFE. It is placed near the end to formally acknowledge team members and show proper project documentation. This section ensures the user leaves the program with clear results, understandable recommendations, and proper project credits.
The last section handles the database operations and the complete execution flow of the assessment. Database controls begin with initialize database, which creates the SQLite database and the table used for storing assessment results. The program also contains functions for viewing all saved records, viewing details of a specific record, updating fields, and deleting entries. This function gives the system long-term usability, allowing users to track multiple structure assessments over time. Saving assessment is handled by Save Record. After the user finishes an assessment, they can choose to save it, attach a structure name, and add notes. This makes the program more practical for real engineering applications. The run assessment function is the core workflow controller. It executes every major step, displaying the header introduction, collecting all inputs, computing the deterioration factor, estimating remaining life, summarizing inputs, showing results and recommendations, and concluding with the team section. It also asks the user if they want to save the data, making the system full interactive. Additional helper functions such as prompt for ID and interactive update are used to maintain proper data validation inside the database. This last section completes Structure Life by making it not only a calculator but also a functional assessment management system.
Welcome to STRUCTALIFE, the lifespan assessment tool for aging civil structures. Today, we will go through a detailed example of how STRUCTALIFE evaluates a structure and provides actionable insights. The process begins at the main menu, where the user selects option 1, Start New Structure Assessment, which initiates a step-by-step evaluation of the structure's condition and expected lifespan. Once the assessment begins, StructaLife displays a welcome message highlighting its purpose to help users evaluate the condition and remaining lifespan of civil structures. The system emphasizes that it provides clear, data-driven insights into deterioration, structural health, and long-term performance. It assures users that whether they are assessing small components or large infrastructures, the tool supports informed, reliable, and timely decisions. The first step in the assessment process is gathering basic information about the structure. This is essential for producing accurate results. Users are prompted to enter the design lifespan, which represents how long the structure was originally intended to last under ideal conditions. In our example, the design lifespan was set at 75 years. Structalife then confirms this input and prepares for detailed structural evaluation. The system next guides the user through a series of structural condition ratings. Each ratings ranges from 1 to 5, with 1 representing the best condition and 5 representing the worst. The first category is cracks. A rating of 3 was selected, indicating minor visible cracks that are generally not harmful to the structure. Next is corrosion, where a rating of 2 was entered, suggesting minor surface rust that does not significantly affect structural strength. The deformation rating was also entered as 2, representing slight deflection that does not impact performance. Weather exposure is rated as 4, meaning the structure is frequently exposed to harsh environmental conditions. Pollution was rated as 3, indicating moderate urban or industrial pollution affecting the structure. The seismic risk rating was entered as 4, showing that the structure is located in an area with high seismic activity and frequent tremors. The traffic load is rating as 4, reflecting high usage with constant heavy loads, and finally, maintained was rated as 4, meaning the structure receives regular high quality upkeep and repairs. After rating the structural conditions, StructaLife requests information about the current load compared to the design load. This represents the actual stress or weight the structure is carrying to its maximum design. In this example, the current load was set at 85% of the design load, indicating that the structure is operating near its intended capacity. Once all inputs are collected, StructaLife summarizes them in a clear table, allowing users to review the ratings for cracks, corrosion, deformation, weather exposure, pollution, seismic risk, traffic load, and maintenance, along with the current load percentage. This summary ensures that all data has been correctly entered before calculations proceed. StructaLife then calculates the deterioration factor, which quantifies the accumulated structural wear on a scale from 0, representing perfect condition, to 1, indicating maximum deterioration. In this case, the deterioration factor is 0.51, suggesting moderate deterioration. Based on this calculation, the system assigns a categorical condition rating of fair, meaning the structure is generally acceptable but requires monitoring. Using these factors, StructaLife estimates the remaining lifespan of the structure. For this assessment, the structure has an estimated 48 years remaining, down from its original 75-year design lifespan. The system also provides actionable recommendation for a structure rated as fair. The recommendation course of action is to continue regular, scheduled maintenance and routine monitoring. This ensures the structure remains safe and performs reliably over time, while preventing further accelerated deterioration. At the conclusion of the assessment, StructaLife prompts the user to provide a name or identifier for the structure along with optional notes. In this example, the structure was named the Cultural Center of the Philippines, and the user chose not to enter additional notes. The system then asks whether to save the assessment and the database. By entering yes or Y, the assessment was successfully saved with an ID with future reference, ensuring the data can be retrieved, reviewed, and updated as needed. Finally, StructaLife displays a closing message, thanking the user for trusting the system. It emphasizes the commitment of the team behind StructaLife to provide accurate, reliable, and data-driven assessments to support the longevity and safety of civil structures. The team members, Conrad Jefferson F. Bagos, Patrice Angel M. Coronel, Kyla R. Lelucin, Miracle Angelica D. Macandili, and Green Angela De Cebu are acknowledged for their contributions in developing and maintaining the system. In summary, the Structural Life Assessment process is a structured step-by-step evaluation that gathers critical structural data, calculates deterioration, provides a condition rating, estimates remaining lifespan, and recommends appropriate action by following this systematic approach. Engineers and facility managers can ensure that civil structures are properly monitored, maintained, and safeguarded for long term performance and safety. And that would be all. Thank you so much for listening.